Analysis by the U.S. National Aeronautics and Space Administration, NASA, suggests that Venus may still be geologically active. The results of the study, published in the journal Science Advances, state that the surface of Earth's neighbor planet closer to the Sun is still being shaped by activity from within, more than 30 years after the Magellan probe mapped its surface. Scientists have found evidence of hot material rising from Venus' interior, an indication that geological processes are still taking place there. The discovery strengthens the case that Venus has internal dynamics more similar to Earth's than previously believed, even though the planet lacks plate tectonics. This research provides new and important insights into the subsurface processes that may still be shaping the surface of Venus today, said Gail Cassioli, a scientist at NASA's Goddard Space Flight Center who led the study, as quoted by Live Science. The study focused on dozens of large ring-like structures on Venus' surface called coronae. These structures form when hot rock from the deep mantle pushes the crust upward, and then the surface collapses, forming a circular pattern. Cassioli and his team simulated the coronae formation scenario, and compared their results with data from Magellan. The results of the simulations and the real data matched for a number of coronae, surprising the researchers. "We couldn't believe what we were seeing," Cassioli told Scientific American. Of the 75 coronae analyzed, 52 appeared to be sitting on top of a light mantle plume. This finding suggests that there are likely active processes going on that are shaping these features. "We can now say that there are likely to be multiple active processes going on that are driving their formation," said Anna Gulcher, a planetary scientist at the University of Bern who also led the study. "We believe similar processes occurred early in Earth's history. Venus is known to have hundreds of coronae, most of them in regions with a thin, hot crust. Recent simulations suggest that Venus crust could crack or melt when it reaches a thickness of about 65 kilometers, and could be thinner in many places. That's very thin, considering the extreme conditions on this planet," said Justin Filiberto, NASA's deputy chief of the Astromineral Materials Research and Exploration Division, who co-authored the study of Venus crust. Filiberto explained that this process of shedding or melting the crust plays a role in organizing the surface structure of Venus, and could recycle water and other materials into the planet. This process has the potential to trigger volcanic activity and affect Venus' atmosphere. It reconfigures how the geology, crust, and atmosphere of Venus work, he said. The findings lay the groundwork for future missions to Venus that will collect direct data on the planet's crust and geology. NASA's Veritas mission will map Venus' surface at 2 to 4 times higher resolution than ever before. Meanwhile, the Da Vinci mission, scheduled to launch in 2029, will study Venus' atmosphere and surface chemistry. The European Space Agency is also planning the Envision mission in 2030 to conduct high-resolution mapping. These missions will provide a level of detail that could revolutionize our understanding of Venus geology and its implications for the early Earth, said Suzanne Smrecker, a planetary scientist at the Jet Propulsion Laboratory and one of the study's authors.